Awesome. Well, happy Tuesday. We are cruising along. Believe it or not, this is week 4, um, which is getting close to, not quite halfway through our initial content, but almost halfway through the online textbook, at least the stuff from Dr. Chuck. We're getting there. After today, we'll be pretty close because there's not too much more, and these later chapters are relatively short here. So he's got a little bit of stuff. We'll try and do some more stuff, fun stuff with it in class. We'll do a whole little bit on web services. This is lots of fun. Spend a lot of time on objects and testing. I'm big on unit testing. Working with databases is fantastic. And anything and everything in the world nowadays is in a database somewhere. So being able to interact with one within code is super helpful. That way we can work with data that's somewhere and get data from other sources, these sorts of things here. Got our spring break, and then visualization, and then again the midterm. It's not really mid, but here's the main reference textbook here, and we'll do for midterm after we get back from then. Then we've got a couple weeks on just looking at different Python libraries. So I've got a couple ones I'm working on, putting together the list of ones I want to show you. A lot of fun ones, and then we get to work on our final project. So again, we've got the first project. Project 0 doesn't really count. That was Hello World, essentially, or Hello Me. Then project 1 we've got due on the 30th, and then we'll work on our next project, do the 13th, work on the project after that, do the 27th, and then we've got probably one last one that'll be due by, we'll pretend spring recess doesn't exist, so probably right before the midterm. I promise the midterm won't be high stress. I'll give you a little example midterm, that sort of thing here. You don't have to take it in class. It's open book, open notes, it's untimed. This is really just a chance for you to check, did you get enough out of the reference here, out of this initial stuff in Python here. You don't have to memorize any of it, right? But, oh, hey, I remember that topic, let me go find more information about it. That sort of thing here, just to check for you there. I was supposed to give some quizzes, and I keep forgetting to write them here. So today I'll remember to write your first quiz. They're real short. It's like true, false, maybe multiple choice questions. Stuff I say is fair game, and stuff from the textbook is fair game. I think I admitted one of the reasons I give quizzes is to make you go look at the book, right? I get it. I went through school without opening a whole lot of books and a whole lot of classes. But you're going to learn much better the more repetition you get. So I'm going to try and give it to you one way. The book will give it to you another way. You'll practice it another way. You'll have your projects to practice it, those sorts of things. So doing it over and over and over and over, by the 4th or 5th time here, hopefully it's going to be stuck in your head a little bit better. Memory works kind of funny like that. If you cram it all in one day, it's going to fall out much faster. Right? But if you do, hey, you listened to Eric one day, you read the textbook another day, you did your homework another day, maybe you talked to the buddy another day, you're going to keep it in your head a little longer, right? So that's why we've got all this practice here, and the quizzes will make you go look at it again, that sort of thing. So I'll work on posting those. Again, they're going to be untimed, open book, open notes, quizzes. Just, if you don't know it, go find it, right? Oh, maybe I don't remember what he said then. That's okay. Just go look it up. Right? It's either something I said or from the textbook here for that. If you've got questions about my questions, please feel free to ask. Right? I write them. There's no question bank out there for this. So sometimes what I have in my head for a question doesn't actually come out on what I type, and it just doesn't make any sense. It's happened before. That's okay. It's not a big deal. I'm happy to clarify. Right? And then our final project, then we'll start on 319. So we've got essentially the last month of class to work on it. We'll do it in groups. I think with 60 people, if we do groups of 4, we should be in pretty good shape because we can get 15 groups to present in our final presentation slot here without too much hassle. Each group takes about 5 to 10 minutes. If each group takes the full 10 minutes, then we're at 2.5 hours out of our 3-hour block. It should be great. Most groups get it done in 5-ish or so. You're just going to show what you did, right? And then I might have a question or two about your code, questions from the audience. Ideally, we're not all doing the exact same thing, and it'll be much more interesting, which would be kind of fun. So we'll get into that as we go. I got some fun ideas. Do you guys know we have a librarian dedicated just for the College of Engineering and Computer Science over the library? I can't pronounce the I'm not even going to try. The library. She's really cool. So she's going to help us out with the final project, doing a little bit of research here on some stuff here, which should be fun. So I'm still sitting down with her, meeting with her, trying to tackle all this stuff. She'll probably be able to come one morning and give us a little demo. I don't know if you've used any of the research databases before. Yes, a couple, one head on. A lot of really cool stuff out there here. So we should be able to get a little bit of information out there, have a chance to go find something, and then do a moderately interesting project. Don't set the bar too high. We should be able to do something kind of fun with Python for your final project, a little bit data science-y, that sort of thing, kind of exploring some of the libraries out there. It should be a lot of fun. So believe it or not, we've planned your life all the way through April. Congratulations, you have nothing else to do, right? You don't have other lives or classes or things, right? Okay, maybe you do, but starting 319 or so for the final project. I love when groups get it done early. If you're done by this last week here when we've got final project time, you just put your little bit of polish on, when you guys get together. That's fantastic. You can focus on your other finals. And then all you got to do is just show up and run it, essentially. So that's the goal. If you got to take it in the finals week, that's up to you. However your group wants to manage that's perfectly fine. And then I do have a group evaluation that you fill out here. I don't believe freeloaders should get grades. So if all of your team says you contributed nothing, you don't get a grade on the final project and you fail the class. Right? Without the final project score, you cannot pass the class. So if you screw your group over, you will fail. Just fair warning, right? And I think everyone should think that's pretty good, right? You don't want someone to get by off of your efforts. So you got to contribute. That's why we've got the month to work on it here, right? I know things come up. I know people are busy. But you've got to be contributing to the project. Now, that being said, we'll be fair and honest. I don't expect every single group member to be the most fantastic, put together, got everything 100% done early sort of thing. That's okay, right? An average contributor is okay. It's not great, but we can work with an average contributor, right? You're not going to fail if you just did an average amount of effort. Right? It's only if you just screw your group over and don't do anything. Like, oh yeah, I'll take care of that, and then you just don't do it. That sort of stuff, okay? So that should be fun. Is that a question? Or okay. All right, awesome. So we're getting into lists, dictionaries, and tuples or tuples. I always say tuples. Some people say tuples. I don't know if one's actually correct or not here, and it's just fun to say. So let me fire up PyCharm. And I'm going to do a new project. And make sure I put it in the correct repository. If you put your code in your repository, you'll be able to use it, find it in GitHub, commit and push, sync with the cloud, that sort of stuff. Feel free to put whatever you want in your repository in there. I'm just going to look at the stuff for the projects, right? Or the grader's going to look at the stuff for the projects. And you might see a note asking to re-invite her to your repository. She didn't know the links had a 7-day expiration. So she got through some of them, I think. I'm sitting down with her today for some of the projects, and then was like, oh, I'll just accept them as I go. We might change something here. I'll chat with her and see. This is week 4. Lists, tuples, and dictionaries. I think I figured out the bug that I was having with my Classroom GitHub tool, which makes repositories automatically and gives everybody access. So that would save one little bit of hassle. I'll talk with her and see. All right. So we did like the super basics of lists, right? Where we access stuff by index, and we said they're basically like a vector. Did we get that far with lists? Okay. So other fun things we can do with lists, which are really cool. So we said, I don't know what, some colors maybe is, so square braces are for lists here, and you just give it a bunch of things here. So we might say, blue and red and orange and green. Got some colors. Yes, yeah, so you can also, because Python is fun like that, add in all sorts of different things here, like integers and floats and strings, and you can even throw objects in lists here. Nothing stops you. I'm going to say it's ugly and don't do it. That's probably just bad practice, because then you've got to remember what's where and what type is where, and that's just super confusing. We just haven't done objects yet, which would make this a whole lot easier. So don't recommend adding weird stuff like that. Here, I'll just leave that commented out here. Don't all have to be the same type. Look at that. I do know how to use comments occasionally. I just hate them. So we've got some colors here, and maybe we'll want to ask the user, what's your favorite color? So maybe your favorite color is an input of, what's your favorite color? Now, all of these are lowercase here, and remember, Python's case sensitive, so capital R red is not going to match lowercase r red. So I might want to make this lowercase here. You can say dot lower, we'll lowercase your input so that I can check if it matches a little bit nicer here. Now, what we probably would have done before is something like a little loop. We might have said, hey, for color in colors, I'm sorry, some colors here. If color is equal to the favorite color, we'll print, we have your color in the list. I don't know, something like that. And now we can't really do an else though, because we're looking at every single color here. So we might, to say if we don't have it, right, well, we could set some sort of flag, right? Maybe I said, hey, you know, found favorite color is false. We'll assume we didn't find it, and then if we did find it, we'll say your found favorite color is true, and then maybe if not found favorite color, print, sorry, we don't have your favorite color. Like, this is a little bit obnoxious here to be like, is your color in this list or not here, right? And turns out, yeah, that's really annoying, and we don't have to do it like that. Python gives us an operator we can use to see if something is in a list or in a collection here. And say, hey, if favorite color is in some colors. It's really, literally just called in here, which is fantastic. Then we can print found your favorite color, and then otherwise, right, we can attach an else, say, nope, we don't have it. So this in operator checks for values in a collection, which is really handy, really nice. Again, it is case sensitive, right? So favorite color, if it were lower casing it, we can check here. Now, if you don't want to mess with their input, you could also move the lower down here and say, hey, if favorite color lowered here is some colors. Now, remember, strings are immutable. So what we're doing here when we lowercase this is we're generating a new string and saying, hey, is that new string that's the lowercase version equal in this collection here, but it's not going to change their favorite color in case you wanted to spit that back out with whatever casing they gave you here later on. You got choices. Either way is going to work for you. Just depends how often we want to check this, or we want to be able to modify that sort of input. So that's kind of fun. So we can just check real quick, hey, is it in the list? Works out really nice. Other things we can do with our lists, you know, we can take two lists and stick them together. Works out really nice. So if we had our list of colors, and then maybe we had, I don't know, the fancy colors or something. That should be colors, right, with a U, if we're going to be fancy here. There's maybe another list, like fuchsia. I'm sorry?
Lavender.
What's that?
I said lavender.
Lavender? Yes, fuchsia, lavender, magenta. So I think, because I'm a squirrel, magenta is the one that's not a real color, right? We don't have a color cone for magenta in our color cones in our brain. So no one actually knows for sure that the magenta that you see is actually the magenta I see, because we don't have color. Our brain literally just makes up, oh, I think this is probably what it is, which is always a fun one here. Did I spell fuchsia wrong? I probably did. Typo. Fascia? I don't think that's right. Maybe I'm just too far off here. That's okay. Is it an H? Fascia?
Maybe not. Now it looks wrong.
Replace with SIA. Fuchsia. Fuchsia. Okay. Sure. It's kind of sad, actually. My last name, Charnesky, is pronounced with like the SH sound, like Charmin toilet paper, but it's a CH. and the same CH is making the SH sound again, and I forgot. So that's a fun one. Anyway, so if you have two lists here, we might have like all colors will be colors, some colors plus fancy colors. Fancy colors, right? Just add the two together here. And then we could print it all out, all colors here. And we give it a little run. So our favorite color, red, we see it's in the list, and then we see here's all of our colors, right? First list, second list, just concatenated together, gave us a new list, right? Yeah.
This is more actually within the dictionary section, but it mentioned this has like a function for list. It starts with ODR or ORD. I don't know if you know what the function is. ORD.
So usually that's to get the ordinal value of something. But that's like a particular letter at a time. You can get the ordinal value, like we did for like shifting everything down by one letter. I'd have to look and see where he was using it with dictionaries. Yeah, I can take a look in a little bit. So pending is great, works out pretty nice. You can look for intersections, differences, and unions of different lists here, which can be kind of fun if we're doing more sort of like set operations. They take this one and do one of those set things. We've got built-in operations for that. Some colors, and you just say dot, like you can see a couple other options here. Sort will sort your list in natural order. So for strings, it's by letter. Remember, uppercase letters are smaller than lowercase letters because of how we store them in the Unicode value. That one's a little bit awkward with letters sometimes, but numeric values sort really nice. Reverse just reverses it. Insert can put something at a given index in your list because lists are ordered. Hey, I want to be like the new, let's do all colors here. All colors. And we want to say insert at, let's see, so this is 0, 1, 2, let's put something here. So we want it to be the new index 3. So if we insert an index 3, all of these ones will just shift down to make room for the new index 3, right? So let's insert at 3. Which one did we forget? How about purple? We'll put a purple in there at index 3, and then we can print all colors, and it should look like what we expect. Favorite color blue, and now we get purple at index 3, right? So we get that one out here with our all colors. You can remove an item. Removing is by value. It removes the first occurrence here. So we wanted to remove, let's get rid of fuchsia because no one actually knows what that color is here. So it removes the first occurrence by value. Occurrence, is there an E there? Occurrence, nope, occurrence. All right, the spell checking just drives me crazy sometimes. 2 R's and an E, there we go. You can also use pop. So pop by default will remove the last thing here. So this would remove magenta, or we could say, hey, all colors dot pop a specific index. Hey, let's get rid of red at index 1 here, right? So this will get rid of fuchsia, it'll get rid of magenta at the end, and it'll get rid of red at index 1. If you remove something in the middle, remember everything has to shift down. So that should trim out our list a little bit here. Give blue, right? We got rid of red, we got rid of fuchsia, we got rid of magenta. We're left with just these ones, right? So lots of ways we can mutate our lists, right? They're mutable. We can change them here. They're very dynamic, relatively easy to work with here. Now, if you remember back to 200 here, some things are fast and some things are slow, right? Screwing with something at a particular index means everything after that index have to go and shift to take its space. Here, whether or not we're removing or adding. So the bigger number of items you have in your list, the bigger your n is, the slower that is, right? It's an O of n operation for those who care about performance sorts of things here. So just be careful, it can get slow. Relatively slow, right? Depending on how big things are going here. Removing by value has to look at every single value till it finds one, right? And if you typo this because you don't know how to spell fuchsia, we try and remove it. It says, oh, it just crashes on us. That's not in your list here. Uh-oh. So we got to use a try except block here for this. Did we get to our exceptions? Good. So we could just try, right? Try and accept. Now this one is a value error as error or something. I don't know. Print error. Sure. Now it shouldn't crash on us. We'll just get our nice little error message here. and we get, hey, oh, X not, that's not a super helpful error message though, is it? But, oh well, you know, we could do better later. And X not in list. No, that's not what you want to tell your users. But again, this wasn't user input. We didn't ask them what color to get rid of out of the list here, so this is just our own fault for hard coding this in. But you know, again, maybe we'll leave that as a to-do. Make this better. A better message for a user. Right. That's tomorrow Eric's problem, not today Eric's problem. So, all right. So fun things with lists. Let's go check out PY4E. I just want to make sure I'm not missing any of the big pieces here. Oops, it's HTML book. For lists, nope, that's files, can't click. Mutable, traversing lists. Okay, yep, so when we loop over lists with that quick little enhanced for loop, let's say like for color in all colors, and if maybe I wanted to say color equals color.upper, let's make this uppercase, and then we'll print the color. You just want to scream these colors at people here, because, you know, why not? We get them all uppercase. Right? Not super exciting, but then if we were to go to print our all colors list here, are they going to be uppercase or lowercase? What do you think? Lowercase. Yeah, so we've changed a copy here. So this gives you a copy of your items, essentially. Not exactly the case when we start dealing with objects, but again, for now, call that good. We can come back to that when we get to objects here. So now we get, hey, they were uppercase, but they weren't changed here. So if we want to change them in place in the list, we can do that. We can say for index in range, the length of my all colors list here. And if I go by index value, right, I say, okay, my all colors at the index here will equal my all colors at the index dot upper. Right? Now we're changing what's stored in the list here, because we're going directly to that index in the list, changing the value that's stored here, not just changing the copy that we have here. Then when I print it out here, now we get my all uppercase colors, and we're very excited. There we go. So we changed it within the list. Yeah.
Can you scroll just a little bit?
Yes, I will pause to drink some more coffee. I'll post all the code too later on GitHub. All right, so they're mutable if we change what's in them at an index. If we're just looping through with a copy, we're not changing anything other than the copy here. So just be careful with those ones here as we go. List operations. Ooh, slices of lists. This is fun. So did we do slices of strings yet? Substrings? Okay, so we didn't get to that yet. That's all right. So this is a single index here. The fine folks at Python said, you know, it's kind of common to get like chunks of things here. Hey, I want to go get from this index to another index. You know, give me a subset of your list here. So we could say, hey, I want to print all colors. And now what you do is it's the same square brace notation, but we're going to give it two numbers. You're going to give it the starting index here, and you're going to give it the ending index. So hey, I want to go from 1:3. So this is start index colon end index not inclusive. So you don't actually get the ending index that you ask for. You stop just shy of that ending index. So 1:3 will give me index 1 and index 2, but it won't touch index 3. Right. Seems a little bit awkward, but what that lets you do essentially is you can use the length of your list as your ending point and not go out of bounds of your list here, which is kind of nice. So we run that one. We'll get just the subset here, indexes 1 and 2. So you can take a slice here, this is slicing, of that. Now, other cool things we can do here, we can say, hey, I want all colors. You can leave off one of these, or actually both of them really. So if you just say colon here, you've now gotten a slice. By default, no value is 0 for a start. So default start is index 0, and default end is length of the list. Here. So if we don't give it values, we're going to get a slice of everything here from the beginning to the end. here, right? Gives us out the entire list here. We said, hey, just start at the beginning and end at the end. It gives me everything. Now, when we take slices, we're getting copies. So if we were to take a slice and loop through, we'd have a copy. Right? It's sort of like this enhanced for loop. You just get a copy of them here. So giving back copies of lists is a quick, easy way to make sure people aren't going to change the value you're storing for your list. So if we have functions that do something with lists, or when we start dealing with our objects and classes that have lists of data, we could give back slices of the list here to get a quick copy, because I don't want someone to change my actual values, that sort of thing. But you can do fun things. Other silly things you can do with indexing here, you can use negative numbers. So we can say, hey, I want to go to -2, and let's go to +2 to -2. So negative values just say count backwards from the end. So instead of having to take, this is really like the length of some list or of all colors -2. So this is implied when you use a negative value, right? So the length of all colors is 1, 2, 3, 4, 5, 6. 6 minus 2 is 4, right? So this would be index 4, right? So index 0, 1, 2, 3, and 4. But because we're not inclusive of that number, we don't get that one. So we'd only get the first values here, right? So 0, 1, 2. So we get purple and green at this point, because we want to start at index 2, go up to the length -2 here. So that's this with negative index assumes, and then we'll go back and print it again here with the shorthand. So just a -2 says, okay, just go back 2 from the end. And we get our purple and green. So negative indexing is fun, works out pretty well for us. And that way you don't have to go and track the length here and count backwards. It's like, oh yeah, everything but the last 2. Done, -2. Gives you some nice shorthand for that one. You can take some slices. Appending, we've appended the list before. That one's not super interesting. We looked at pop, we looked at remove. If you've got numeric lists, you can max and min really quickly here, which is nice. So if did we look at that with like the lotto numbers or anything? I'll just have some numbers here. I don't know, 1, 2, 3, 4, and 5, not super interesting, but we can get the minimum number here. So the minimum is min of numbers, and we do the max is the max of numbers, and we can do the sum is the sum of numbers, and we can even do the average. Now, sadly, there's no built-in function for average. I don't know why, but that's just sum divided by length of numbers, right? That gets you the average real quick. Min, max, sum, average. I think that all checks out here for our 1, 2, 3, 4, 5 list here. But it's nice to have some built-in functions. Right? We don't need to go and reinvent the wheel to get these sort of quick little numeric checks. Yeah.
I noticed the average put that in a float.
Mm-hmm.
Does it try to do that?
I think division usually likes to give us floats. It feels right. Probably does. It did here, so division must give us floats, because that was a pretty easy 15 divided by 5.
Like, what if it was 16? Like, we changed that point to 6.
Sure.
We can see that now.
Yeah. Yeah, 3.2. Yeah, it gives us the float. Yep. If you want integer division, you can use this double divide sign to force integer division and truncate your remainder. Truncate the decimal here. I don't remember if we talked about that back in operators, but you can use force integer division with a double divide sign. It's fun every now and then. Sorry, my sugar's cranky. Wow, it is bad. All right, hopefully that's better. All right, so that's lists. Lots of fun things we can do with lists. I think that's the whole section. Oh yeah, strings. There we go, splitting, that one's fun too. Okay. Yeah, let's do that one. Okay. We'll spend a little more time with that one. So if we have someone enter a sentence here, just why not? So we'll get some input, or I will say our sentence is an input of enter a sentence here. If you want to quickly turn this into chunks here, one word at a time, or divide it up somehow, like split it into different pieces here, there's a built-in function for that. So we might say my words then is equal to sentence.split. By default, split is going to split on white space. If you want to split on other characters, you can give it a specific character to split on here. And we can say for word and words, print the word. Again, not super interesting here. Maybe we want to look for like word count, see which one has the highest word count here. That might be fun. We can do that one. So we'll say for word and words, let's see, we need to have the highest or number of occurrences, right? Highest number of occurrences probably equals 1 to start. Occurrences. OCC. One C. 2 R's. 2 C's and 2 R's? Goodness gracious. Okay. So we can see how many times a given word appears in the words here. So we can say if the words.count of the word is greater than my highest number of occurrences. And then we'd have, I don't know, most common word equals nothing. So actually, let's start that off at 0, right? Because I don't know if I'll ever have more than one repetition here. So if it's greater than that, then our most common word is the word. So counting the word says how many times does something appear by value in your collection, right? So it's just another thing we can do with lists. Say, count how many times this one shows up here. So we don't need to print the word. We'll just find the most common word. Then we can print most common word in your sentence is, and formatted string here, most common word. I don't know. And print, it appeared highest number of occurrences times. Sure, why not? Favorite color blue. All right, enter a sentence. Let's just get, I don't know, some random poem. That's probably a good sentence here, right? I gotta put that all like on one line, don't I? Shoot. Oh, that's annoying. Here, hang on. Let me open up code. Come on, I want a new file, new text file. There we go. And we'll replace, what is it, the $sign? There we go, with space. No, come on. Backslash n. There we go. Replace backslash n's. Spaces. Hey, there we go. Now I have a single line. That was fun. Enter my sentence. Uh-oh. None of them repeat? Really? Really thought we would have had a repetition here. We should have had I. I should have repeated here. Oh, we never reset our highest number of occurrences here. You guys let me do a dumb thing and didn't yell at me. Highest number of occurrences equals the count here then. Now we've reset that counter here. Otherwise, everything appears more than 0 times. Let's try that one more time. Blue. No, I have to paste in my poem again. Hey, it is I. Look at that. It appeared 8 times. That worked out pretty nice here. You guys are all very excited with that demo, weren't you? Very worth your time. I don't know. Fun things you can do in Python relatively quick with some fun list operations here. Counting things is sort of fun. And he loves going through and parsing things here. Strip is nice. It takes out extra white space. So as we're splitting things up, if we didn't split on white space, then we can go take out the white space. If we're dealing with user input, maybe they had some extra spaces in places. This is the right strip specifically. Assigning a list to another list doesn't give you a copy. It gives you, it's essentially a pointer. Right now we have 2 things pointed to the same location, right? Because the value of a list is where it is in memory. for our actual variables. Like the variable A says here, my list is this place in memory. That's all. The fun thing is when lists store values, everything stored here is actually like another reference. So it's not storing the literal value 1, it's storing where are we storing the value 1 in memory. So when we size lists, they're always going to be the size of X number of memory addresses, which works out really nice. And then list arguments, sure, appending, printing. All right, cool. I think we did pretty good here for lists. That one, relatively straightforward, I feel like. Kind of tracks pretty well from vectors. We can do interesting things with vectors. Now, dictionaries are probably brand new for you. These are not relatively common for us to get talking into in C++, at least at the beginning here. So these are key value pairs. A map, yep. So there's a key, and it is associated with a given value. Now, an important piece to know in dictionaries is that your keys have to be unique. Right? And the reason is you can't have more than one key at a time in a dictionary. It just doesn't work. Now the syntax for dictionaries is a little bit awkward here. Let's actually bump this up to the top. Why not? Here. So for a dictionary here, so this will be, I don't know, like how about grades? I always like to use that as a fun example. We use curly braces. So curly braces mean I want to start a dictionary, and I can give it initial values if I want here. So I can say, hey, Eric, and then colon, the value I want to associate with Eric is of course an A. Right? If I teach the class, I get an automatic A. It's only fair, right? So there's the key and the associated values. This is key value pairs. So key, colon, value. And then if you wanted to have more, you just comma separate them. So like, okay, my son Jeb was following along on YouTube like I try and make him do. He's not doing so hot following along on YouTube because he's 17 and thinks he has better things to do with his life. I don't know why he wants to have a life, but that's okay. Probably a good thing to have every now and then. So just comma separate your pairs in here. This sets up our dictionary, right? Now if I wanted to add to a dictionary, we would say grades. Again, I didn't write it, I didn't come up with it. We just have to learn to work with it here. Key of, so it's not index of when we talk about dictionary, it's the key of. And then let's add, we'll say journey here. So let's see if she wants to take the Python class. Maybe we'll assign the value of C to her. So this will add a key and associated value. Associated value. So it's going to look up in my dictionary, see, do I have a key of journey? No, I don't. I'm going to go add it and associate the value of C. Yes. So then be like, oh, hey, Jeb decided to finally turn in some homework here. So say, hey, dictionary key of Jeb. Let's update the value here. Let's say now he's got an A. This is updates a key with the associated value. Can't spell associated value. So the exact same syntax is add or update. So if the key exists, it updates. If it doesn't exist, it adds. And this is why you can only have one key, one unique instance of each key, because it adds or updates. Right? If I run this line 3 times, I added it, then I updated it, then I updated it. I don't have 3 more instances here, right? Because once it's there, it just goes and updates. That's all. So weird syntax for that, but there you go for dictionaries. So if you know your values, you can start with them. If you want to then go add them as we go, great here. Then when we're looping through dictionaries, we get all sorts of weird stuff here. So I would say for, now when you use the for loop, for item in collection here, we can do that with dictionaries, but we're only going to get the keys out. So really it's for like name in grades. I can print the name. I'm only going to get Eric, Journey, Jeb, because I got the keys out, right? If I wanted to get their associated values then, let's do this as a formatted string. Here's the name. To get the value back out here, we then say, I don't know, maybe a colon, your dictionary key of your key. This gets the value associated with this. So if I'm not assigning to it, I'm using this exact same syntax now to go get the value. So it adds the value, it updates the value, or it gets the value. Which is a little bit awkward here, all with that same syntax, because sure, why not? So now I get, here's the name, and here's the associated value. Here's the name, here's the associated value. Here's the name, here's the associated value. We can get them all back out. So the in operator here, this is for name and grades, doesn't check to see if it exists. Yeah, sorry, go ahead.
Can you do another loop like that, but do like the dual iterators? So
Yeah.
like you can tuples.
Yep.
Do that with
Yep. So if I wanted to use the in operator to see is this name in the gradebook here, like hey is we'll see if like Jubilee's taking my class here. So if Jubilee is in grades, print Jubilee is in the class, else print she's not taking the class. She is not interested in computers at all and is breaking my heart, but that's okay. So the in operator checks for a given key. Doesn't check for values, it checks for keys. Right, so we got to be a little careful with the in operator here because it worked for list. Is this value in the list here? But if you ask, is this value in your dictionary, it only looks at the keys. Okay. Other things we could do then, so with our grades dictionary or any dictionary here, we can get out other things. So he had just asked about getting both items at a time. Well, we can do that if you want. So we could say for name comma grade in grades dot. Now, if you just say grades dot, you get a bunch of things here, right? We get values, we'll give you the list of values, just the values, which I feel like is not very helpful without the associated key. But again, depends what your dictionary is storing, I suppose. Keys gives you the keys. We got this one by default here, but items gives you the key value pair items. And because Python is so friendly, it says, hey, if I know this thing's going to give me back two things, and will pack them together for me, I can unpack them automatically. I'm expecting to get two things back every loop. I can go and unpack them as name and game. Oh my goodness, what did I do? Name and grade here as we go. And I can just print name and grade this way. Name and grade. Right. So this will give me all the items out with a loop this way. Again, we're getting copies when we do it this way, essentially. We're not changing anything. But there's another way to get those values back out as we go, right? With the items here. Now, this syntax, we say, hey, grades index of or key of to go and get a value out here. So if I wanted to go print, this is formatted string, Jubilee's grade. I can use double quotes, Jubilee's grade is, and then use my grades dictionary, key of, Jubilee is the key here. If it doesn't exist here, we get a, key error, Jubilee. This key is not in the dictionary, this fails. So this is gonna crash here. So we can do a try block, right? We can try. Now, try and accepts should be reserved for exceptional cases here. So we totally could do this here, but it's bad practice. Except key error as error or something and print the error. Sure. Technically this is fine here. Oh, the error is just Jubilee. That's not a very helpful error actually, is it? But this is bad, bad form, because relying on an exception is gonna make your program slower, right? Exceptions should be for exceptional cases here. Do we have a way to check if Jubilee's in the gradebook before we do this? Yeah, we just check, hey, if Jubilee's in grades, then we go do that, right? So, yeah.
Isn't there a method of get?
Yes. Yeah, that's the next one. Yep. Yep. Thank you. So we should avoid and use an if check, if in check first. So checking if something is in the collection is much faster than trying and handling an exception, right? Because exception handling kind of breaks the flow of our code and makes Python do extra work. In any language, it makes that language do extra work to do that exception handling. So if we can avoid it, let's do it here because it'll be a little bit faster. So it's technically fine, but just consider bad form here. Now, the other option we have is we've got other methods of dictionaries to go and get values out. So one more time, we could say, hey, not grades key of Jubilee, but grades dot get. And get, it says, oh, give me the key, so key of Jubilee here. Again, if you like your functions, you like your methods, we can do it that way. But now we get Jubilee's grade is none. None is the fancy Python word for null. Right? You got, it doesn't exist, it's not here. Okay, well, we could check for that sort of thing here, but at least we didn't crash. It's a little bit nicer here. And the other thing you can do with Git is you can give it a default value. So if it doesn't return anything, if it doesn't exist, instead of getting none, what do you want it to give back? Right? And maybe we give it a message like not in gradebook. I don't know. Maybe not the prettiest message here, but that's okay. And we give it a run now, and we say, hey, Jubilee's grade is not in gradebook. Slightly more meaningful, maybe. So Git have an optional return value. Defaults to none. So lots of fun things we can do with that one here. All right. Now, one of my favorite examples to do here, because it's lots of fun here, we're going to import random. We can generate some random numbers here. I like shiny math rocks. They entertain me here. So we're going to see how good Python's random number generator actually is. If we wanted to pretend it was a 6-sided die and roll it a bunch of times here, what kind of results are we going to get back out? Right? We can do that sort of thing. So, excuse me. So I want to make a dictionary with the number of times that I've rolled a given number here, right? Now, I could go make the dictionary by hand. So this is my, I don't know, roll results here equals a dictionary. And I can say, hey, the number of times I've rolled the number 1 is 0. The number of times I've rolled a 2 is 0. I don't really want to have to type a whole lot though, right? I'm kind of lazy here. Is that okay? So maybe we say for die value in range 1 to 6, but remember we want to include 6, so I'm going to go from 1 to 7, so it stops before we get to 7, so I get 1 to 6 here. And then I can take my roll results, key of the die value, associate a value of 0. So now I'm going to go load my dictionary with 1 has occurred 0 times, 2 has occurred 0 times, 3 has occurred 0 times. I suppose this is less typing than 1:0, 2:0, 3, now I don't actually know if it's less typing or not. I feel a little bad, but that's okay. So we got the roll results. Now we want to go and actually roll, right? Generate the random number. So we could say, I don't know, for roll in range, should we do like 1,000 rolls here? Let's generate the random number. So we're going to take my roll results, key of a random number, random.randint. Let's do a random number, 1 to 6. Because randint is inclusive, and I hate it here, I just always remember it now because it irritates me so much. Nothing else is inclusive of your endpoint except for random int. Of all the things Python, like, come on. But it is. So 1 to 6. We'll take that value then, and we'll say plus equals 1. Right? Add 1 to it. The value I got back out here is, right, because this is the key, the value is how many times that number was rolled, started at 0, add 1 and assign it back. Add 1 and assign it back. Okay, I randomly generated a 3. I've now rolled a 3 one more time. Right? We'll do this 1,000 times here, and then when we're done, we should be able to print our roll results. Here, let's see what we get out. 136 times we rolled a 1, 190 times we rolled a 2, 176 we rolled a 3, 200 times a 4, 155 a 5, 145 a 6. It's not perfect. That's okay, right? It's not supposed to be a perfect distribution. Here, it's supposed to be relatively random, right? If they all looked the same, we'd feel really bad, because then something's really screwed up if it's like generating every other number is a 1, a 2, a 3, a 4, a 5. That's not random, right? So we expect a little bit of variance here, right? Does that make a little bit of sense? Okay, now the next fun thing, like, hey, if we were playing Monopoly and you have to roll 2 6-sided dice and you move that distance here, well, you and I probably know the most common rolls is 7, because we all like dice, right? You know that off the top of your head. The least common rolls are 2 and 12, right? Because your combination theory and stuff like that. But let's make Python figure it out for us here, right? So instead of going from 1 to 7, let's go from 2 to 12, or to 13, right? Because I'm going to sum up the 2 of these dice here then. So we'll do random number 1 to 6 plus a random number 1 to 6, right? Roll 2 6-sided dice and count them, right? Count the sum of that here, and we'll print our results. Now we should see a relatively good bell curve here, right? 2 and 12 should be the least common, and then increasing in how often it occurs here, with 7 being the most common. Look at that, it looks like it checked out here. Now, this is probably not the prettiest looking output here, right? Not the prettiest looking thing. Can we do better? Y'all like ASCII art? Yeah, we could use a library to actually graph it here, but I'm feeling lazy. Actually, no, I'm feeling like I want to do more work. The graphing would be easier at this point, but that's okay. So we'll print the roll results, but then let's print a nice little chart here, right? We can make ourselves a little histogram. because why not? This is fun. So we'll say for, now we want the roll, right? A 2, a 3, a 4, a 5, whatever it happens to be here. So for roll in my roll results here, that's the key, right? So I'm going to print the key. So I want to print the formatted string. I want the roll itself, and then I want a colon here. Now, if I want to make sure all of these line up here, I forget here. So Python print integers with 2 digits always. I don't know. We'll see if that comes up with anything good here. It's like this costs them money every time they run an AI query here. Like not an insignificant amount of money either to do this. So colon 02, fill. Is it might be fill format? Okay, sure. Colon 02. Let's try that. But here's my code here. Colon 02, and then I don't know. This is. I'll cite my source here. We're going to be a good practice, right? So this was Bing AI query. Sure, right? I cited my source. I didn't remember how to do it. It's probably in our book somewhere, but I didn't care to go hunt through it. I thought that might be faster here. So now we'll get 02, 03, right, to make the padding a little bit nicer here as we go. So we'll get the roll. Then we want to print a histogram, right? How many times did it show up here? So what I want to do then is I want to take the star character and I want to print it the number of times it showed up. So I can actually multiply it, right? Python lets you multiply strings, because why not? So I want to multiply it by my roll results key of the roll. What I get back from this is how many times was that rolled, right? Because this is saying, hey, go to your dictionary, look up this key, give me the value associated with this key. Right, so we should get a nice, pretty looking output here. 2's this, 3's this, 4's, 5, 6, 7, 8, 9, 10, 11, 12's. Right, let me zoom back out here and we'll see 7's was the most common. And we have a pretty little histogram here. Worked out not too bad. Now, pretty decent curve with just 1,000 rolls. Right, we feeling good about that one? What if we wanted to do like 3d6 here and generate that kind of distribution? All right, we could. Okay, so we're going to go from what? You know, could we make this a little more flexible here? Let's do that. So let's ask the user, what size die do you want to roll? Right, there's D6, there's D4s, D6s, D8s, D10s, D12s, D20s. There's all sorts of interesting other ones out there too. But if you like your common set for tabletop role-playing games, it will be with those 7. So we'll ask the user, how many sides? So number of sides is an int of an input. Input how many sides are on your die, and then we'll get the number of rolls. Rolls is an int of an input. How many times are you rolling the die? Here, right? So hey, I want to roll a 6-sided die 3 times, or a 6-sided die 4 times. Sure. So now instead of ranging from some number to some number, we'll go from the number of sides, right? If you have 4 dice, you can't roll lower than a 4. We're assuming dice start at 1, that sort of thing. And then the maximum value then is going to be the number of sides times the number of rolls, right? So from 1, so if I roll a 6-sided die 3 times, my maximum value will be 18, but I want to go including that, so I'm going to then go add 1 to it, right, to make sure my range goes through, and set this one up. Now, this one gets a little trickier. I need another loop, essentially here. So I'll have a total equals 0, and then for roll count in range, my number of rolls. Let's take my total plus equals a random.randint from 1 up to my number of sides here. Then we'll take our roll results and add 1 to the key of the total. Right? So as many times as you wanted to roll, let's go roll it here. I don't know what it is here, right? So we'll just loop, get my total, add 1 to that total. So it should be flexible now based on whatever we give it here, right? So let's go and do our little histogram. So let's do a 6-sided die 3 times here. Oh, uh-oh. Key error 4. We broke it here. That's okay. Let's see. So number of sides, comma number of sides times number of rolls. should have been from 3 to 19. The die value. Why did that break? Now I'm curious. Key of the total, didn't have it. Die results, roll results. Huh. I don't know, let's put a breakpoint in and see. It should have worked. We said 6 sides in the die, 3 times, so I should get, okay, yeah. Oh. We don't start at number of sides, right? We start at number of rolls, my bad, right? With a 6-sided die, we can get less than 6, right? That's the wrong number, that should be number of rolls. There we go. Hopefully that's it then, right? So, okay, so 6 sides 3 times. Hey, look at that, we got a histogram. And it worked out right around 11-ish, 10-ish, 11-ish, right? 3.5 is your average on a 6-sided die, so 10.5 is your average. That's pretty close, kind of what we'd expect here. Again, tapering off at the ends as we go, right? We go like 6 sides and 6 times. Look at that, we didn't even get once a 36 or even once a 6 with only 1,000 rolls here. And we've got a pretty good distribution curve here. Do you feel like random's kind of random? And we did a lot of stuff abusing dictionaries, right? Practicing dictionaries, right? Getting my keys, getting my values, messing with getting something out, adding to it, those sorts of things. Was that fun? Okay. I always thought this one was fun, and I like dice. Shiny math rocks are a lot of fun here. All right, so that's some basics of dictionaries. We'll look at some more of the advanced methods of dictionaries on Thursday, and then we'll look at tuples. Tuples are super easy. They're just immutable lists. You can't do all the fun stuff you can with a list. For our purposes, that's it. Right? So if you want an immutable list, you make a tuple or a tuple. That's all. We'll finish out our dictionaries. We've got the first income tax project calculator. Now, I did have lots of questions, so thank you for asking here, because sometimes I assume a lot of things, and assumptions are bad. So in here, I did add a sample output, because one of the things I asked you to do was calculate taxes owed at each bracket. And several of you were like, hey, my total tax is great. What does this look? I'm like, well, you didn't do this part here. So, well, that's okay, right? I'm glad you asked. So again, this is an example, and these numbers are wrong because this is from like last time I did this project, and I didn't update for the new numbers. So please don't compare your output to this output. Just an example of what it could look like. Yeah?
We did 2024 bracket.
Yeah, 2024 single. If everyone uses that, then grading will be really easy for the grader. She's not allowed to pretend like she's a graduate student because the Graduate Employees Organization has issues with that. Again, it's a whole long story here, but they're looking out for you if you're a grad student, making sure you don't get abused. We can underpay the graders, but not our grads, whatever, that sort of thing. So again, if you wanted to have these, great. These are just, I put them out here. This is in one example, right? It doesn't have to match letter for letter, anything like that here, but it's showing, hey, this is what you owed at the 10% bracket. This is what you owed at the 12. This is what you owed at this one. This is what, and it's zeros for a lot of them. For most of us, it's going to be zeros at all these high ones, right? If these aren't zeros, why are you here taking a class getting a degree? That's the question. Yeah.
We are both combined, so that's dynamic. What I mean is, if you don't owe taxes beyond the certain bracket, it doesn't show those.
Okay, sure. That's as long as you're showing like at this bracket and at this bracket, the ones you do owe, I'm cool with that. That should be fine. And then a total, and then the percentages of gross and the percentages of adjusted gross. Yeah.
Accidentally did 25, is that fine?
I don't think the 25 brackets are out yet. Really? The IRS is that far ahead? 2025.
2020 tax brackets are extended to 25.
Oh wow. Okay, sure. Oh goodness though. So yeah, if you use 25, the output's going to be a little off. If you get marked down, let me know. I'll take a look at it.
I can just change it and recommit it.
Yeah, if you change it to 24, that would make life a whole lot easier. Yeah, if you could. Because they're going to look at, hey, if I put these numbers in, I should get this output back out for the grader. That's all. All right, folks, you take care. I'll see you Thursday.